Cooperative inverse reinforcement learning. So, what does all this psychological mumbo jumbo have to do with machine learning? How do these theories relate to issues of alignment between human and AI systems? Potentially everything. For one, it's important to recognize the inherent issues around training AI in an extrinsically motivated way, because it lends itself to over optimizing unintended things and finding sneaky ways to include bias in decision making. It's the machine learning version of the dopamine cycle, like we've discussed in social media. We ended up optimizing for engagement, expecting people to feel more connected and supportive in a global tapestry of peace. Instead, because of how we defined engagement, we've never been so alone as we click and swipe our days away. The sticky issue here is one of trying to define things that are inherently squishy. So we find ourselves coming up with rule after rule, trying to solve symptom by symptom of a problem, which will, invariably, interact in ways we cannot hope to predict. We have a very difficult time communicating to these models our ultimate intentions because we aren't very good at articulating them in a way that humans can understand, let alone a machine. So, what's the alternative? Is there a way we can foster an intrinsic motivation within an AI system to continuously align with not just human intent, but also human aspirations? The most promising approach in the field currently is something called cooperative inverse reinforcement learning, pioneered by UC Berkeley researcher Stuart Russell and many others. The idea is to flip reinforcement on its head, where we do not give an AI the reward function, how it gets rewarded for a task, but instead set it to observing a human perform a task and have the system infer the reward but never truly know it. In other words, the AI is rewarded for continually exploring in a cooperative manner what the needs of the human are, inferred through a combination of seeing and teaching. It's like the AI is our personal apprentice and is intrinsically rewarded by enhancing our own intrinsic values, motivations, and goals. From the paper, key to this model is that the robot knows that it is in a shared environment and is attempting to maximize the human's reward, as opposed to estimating the human's reward function and adopting it as its own. This leads to cooperative learning behavior and provides a framework in which to design HRI algorithms and analyze the incentives of both actors in a reward learning environment. This has significant implications for our partnership with AI in the future as a way to enhance rather than replace or extract. Of course, you run into issues even with this model around what happens when an individual's intrinsic motivation comes into conflict with another's. But there is a lot of optimism with this approach because it can help us point toward the type of people we want to be and help nudge us along the path of what would personally make our lives fulfilling. It also creates a process that is, at its core, human. If we are to be the mentors, even parents of AI, we cannot take that responsibility lightly. Can we spend some time thinking about where we want to land this ship before we launch into uncharted seas? I'll leave you with this. As we all get bombarded and overwhelmed by advanced AI, always come back to a reflection on what are your personal, intrinsic motivations. What brings you into a state of flow? What do you do just for the fun of it, not because it's tied to an external reward? And then how can you use AI to strengthen that? Because this is potentially one of Moloch's greatest weaknesses. When we reduce our dependence on externally driven rewards, following the lead of win-win, and are instead driven by our values and what engages us, we are much harder to manipulate.